Who never dreamt of going to space or sending stuff to space? Here on the IoT Show today, I have Chris. Chris Tacke is working for Hypergiant, a company that sends stuff to space. So we'll chat with Chris, know what it takes to send IoT devices to space, what are the moments that can happen as well. That's today on the IoT Show. Hi, everyone. Thanks for watching the IoT Show. I'm Olivia, your host, and you're here to hear Chris and I talk about sending IoT devices to space, right? To IoT and beyond. That's basically the title of the episode. Chris, how are you?
I'm doing very well. Yourself?
I'm great. Fantastic.
Good.
Here. So, Chris, we had you on the IoT Show recently, talk about .NET for embedded developers. You were already wearing the same shirt. I really refrained from asking you about the shirt, but I will today. But before you tell us what this shirt is about, a little word about yourself. People might not know you, and we'll certainly go and watch the other IoT Show episode with you just after. But for now, who are you? What are you doing in life?
Sure. My name's Chris Tacke. I've been doing .NET and embedded development for well over 20 years now. Anybody else who has been doing .NET on devices probably is familiar with OpenNetCF. I was one of the founders of that. Been doing a lot of that type of work for a long time. I've been working for a company called Hypergiant now for over 2 years, and we do space and defense type applications. So I do software architecture and hardware builds for them.
That's actually fascinating. We'll talk about that, because space is something that lots of us geeks are interested in our dream or, TV shows, whatever. But you're here to share some of your experience in actually sending devices and IoT devices to space and interesting anecdotes. So Hypergiant is the name of the company. Nice shirt. I hope I'm going to get mine at some point. We can trade t-shirt.
Absolutely.
Yeah, we'll do that. Fantastic. So tell me about, you were saying that you guys are working on different types of projects, but sending IoT devices to space.
Sure.
What are the main challenges? We understand the notion of, IoT, want to connect devices to, get telemetry and information from these devices, being able to control them remotely, update over the air, things like that.
Absolutely.
Here we're talking about satellite, something that goes all the way up, that is not accessible. You cannot send someone for maintenance or whatnot. So tell me a bit more about that.
Yeah, really. So IoT, in my mind, when you're launching into space, it's no different than in a factory or something like that. It's just higher consequence of failure, right? It's more expensive to deploy, and if it fails, you can't go fix it.
Yeah.
But right now, the price of launch is coming way, way down with all of these different people and different companies doing rockets, doing deployment. So now we're able to send up CubeSats. And in fact, you can kind of see right here, that's actually the size of a CubeSat. So that one is called a 2U. So that one's twice the size of some of the ones that go up. And so that is the size, actually, of the one that we sent up about 2 years ago now. It was attached to the Cygnus module from Northrop Grumman, which is used as kind of a space like bus. It's used for supplying the ISS. So you can strap things to the outside of the Cygnus module and catch a ride with it. It lowers cost, so you don't have to pay for things like the radio and all of the communications. You just have a cable that goes to the Cygnus and uses their communication modules.
I might bring him to jail for saying that, but it's kind of the Uber Eats of space, right? You just attach your package and send up there.
Absolutely, yeah. You just strap it onto the outside and go along for the ride.
Totally. So you were saying that from your perspective, it's kind of similar to a factory, or it can be, or a factory floor can have specific constraints in terms of, environment that could be stressful for hardware with, dust or pressure or temperature. Here we're talking about different challenges though, right? There's the vacuum, there is the cold, the temperature, there is no radiations?
Yep, you have all of those. In low Earth orbit or LEO, radiation actually is not much of an issue.
Okay.
It's most things can survive, especially consumer electronics. We actually launched standard old Raspberry Pis up into LEO. They had no problem at all from a radiation perspective. Heat is another thing. You go from when you're in eclipse, so in the shadow of the Earth, very cold, to when you're in the sun, especially if you're facing the sun, it actually can get hot enough to melt solder. So you've got those problems. And as you said, vacuum is also a problem. There are things like electrolytic capacitors. If you've got any of those on the board, they tend to explode in vacuum. So you have to do a little bit of work to make sure that you're not going to have those kinds of problems.
So can I send a Raspberry Pi in space?
Yes, you can. You have to take off the power supply modules. And in our case, since we were strapped to the Cygnus, which was strapped to a rocket, which is really just a controlled explosion, they had us take off the transmitters. So the Wi-Fi and Bluetooth and things like that. They're a little nervous about having transmitters strapped to it.
Let's not have a spark that is controlled remotely, triggered, or something like that.
Exactly.
Right?
Even though you're completely shut off, there's no power even all the way through launch to your payload. That's another fun thing. You get launched, and then you get up in space, and then they push you out, and it's not until after you're disconnected that you even power up. So you don't know if things are going to work reliably until they've pushed you away, you've powered up, and then your payload is moved around to somewhere that an antenna can communicate with it. And then you can find out, did we actually power up and did things work? Did we survive launch?
Yeah, interestingly, you just mentioned about the fact we are used to have the luxury of having devices that are permanently connected, right? Or always connected, or worst case scenario, vehicle goes into a tunnel, it's out, it gets connection again, it's roaming or not, right? The worst that can happen is that kind of things. Or not being at an LTE, reach distance or something like that. But here we're talking about a different scenario because things are rotating, right, around Earth. So what is the challenges there?
Yeah, so in low Earth orbit, you go around the planet about once every 90 minutes. And you go from, if you're looking at it from a ground station perspective, so an antenna on the ground that's going to communicate with your payload, you go from horizon to horizon in usually 6 minutes to 10 or 12 minutes, depending on how far down from, directly overhead you are. So you get communication, best case, 12 minutes out of 90, and the communication speeds are reminiscent of the mid-1990s. So really slow communication.
Do you hear the modem bip, bip, blah, 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 blah?
It would not surprise me at all if they hear that on their end.
That's crazy. And that's, not something where you can say, hey, I'm going to log in, do SSH onto that device, and then do my operations, whatnot, right? Or is it?
Yeah, so it really is. It is, you're sitting at a terminal, you SSH in, and then you have to have commands. So you are so limited on time. Typically what you do is you script out or you write bash scripts, things like that, that allow you to do things as fast as possible. So you're saying, send this command that will delete all of these data files I confirmed that I got on my last pass. Begin sending all of these other things and change the mission parameters. Like, I want it to take a picture, but not while I'm connected. So you have to figure out at what time you're going to be over whatever it is you want to take a picture of, send that up, and then hope after it takes the picture, you get it back around, you pull all the data, which usually takes multiple passes. Did I actually get a picture of what I wanted to get?
Fascinating. Yeah. That heavily puts in perspective, how hard or complex, but also how interesting and fun it can be. Any moment, any bummer, I wish the thing was closer. Do you remember?
Yes, lots and lots of them. One of the bigger problems we had one where the clock kept resetting on us, so it's really hard to do something time-based when you don't know exactly what time it is. We also had, on that mission, we had a Raspberry Pi 4, but we also had some Pi Zeros with cameras on them, and they were designed to like take a picture of an antenna deployment so that we could make sure an antenna went up and things like that. Well, because we were not in control of the attitude of the spacecraft, it was on the Cygnus and they were doing things. They had to, I believe, turn the Cygnus either for it was overheating something in the Cygnus itself. So they turned it and basically pointed us directly at the sun for, it was something like 30 minutes. And the Pi Zeros, when we built the satellite, they didn't have good heat sinks to eliminate a bunch of that thermal heat. And they just cooked. Every single one with the camera, all just basically all of the solder, I'm sure, melted and went away.
That kind of defeated the purpose of the mission, or the cameras themselves.
That was a secondary mission. So the primary still was just fine. So we were still able to get data and do what we wanted to do. We just couldn't get photos of the payload itself doing it. That's
awesome. Is Hypergiant hiring? I'm sure people are just like, I want to do that.
Hypergiant is hiring quite rapidly. We do a lot of AI and ML type work, so constantly looking for designers, data scientists. Yes, absolutely.
That's good to know.
Hiring.
That's good to know. I'll check it out. Don't tell my manager. Cool. Chris, well, everyone, if you want to work for Hypergiant, learn more, you can find them online. Chris, thanks a lot for your time. That was fascinating. And I look forward to having you on the IoT Show again. You need to become a regular. There's no reason.
Absolutely.
Okay. Well, everyone, thanks for watching. See you soon. Bye-bye.
Bye.